Afternoon, everybody. Thanks for joining us here today. Can you give me a thumbs up on sound? Great. So I want to thank Alberta Innovates for having us, and thank you all for finding this kind of maybe a niche topic at this conference. We were super impressed at the wingspan of all the different topics going on here, and we're a little more used to being around the wood and carbon themed large conferences, so it's been great to be the only a small group amongst all the great innovation stuff here. So this is going to be a little bit of a structured conversation. My name is Eli Gould. I'm glad to be moderating three really talented people that I want to be showcasing here on some themes that are really dear to all of us. So we've gone over a sequence that we're going to run through. This is sort of like a virtual vertical, if you will. There are people here who are specifiers, software builders, and even automated equipment manufacturers along a value chain that all relates back to carbon. So we're going to go through this with each of these guys speaking about what they do, and then I'm going to ask them a couple more leading questions, and then we hope we can open up the floor to what you guys are interested in. But I'd like to start by having some introductions. So maybe since we're sitting and going in the same order as we're going, Stephanie can tell us a little bit about herself, and we'll kick this off.
Great. I'm Stephanie Fargas, an associate and a specification writer at DIALOG. I'm there to lead dialogue on best practices for sustainable and high-performance buildings, and working with the federal government also to educate on how do you actually procure low-carbon projects and get competitive pricing.
Awesome. I'm Anneli Tostar. I'm one of the founders of Tangible. Tangible is a software platform for embodied carbon and material sustainability management, specifically geared towards owners and developers so that they can see it across their portfolio.
Awesome. Hey, good afternoon, everyone. I'm Eric Law. I'm co-founder of Urban Machine. We're a robotics startup that's building machines for reclaiming lumber from construction and demolition waste.
As you can see, this is going to be a really varied themes here, but we're all in a similar piece of this industry. So I'd like to get a quick sense in the audience. This is such a varied group. Do we have a show of hands maybe of people who are on the actual investment side, first of all, and policy side perhaps, or public sector? And startup or practice community members. Cool, and there's another mystery third, so this is going to be really fun. I will also say the other moderators have done an awesome job, and I have to start out by saying I'm American, so I'm going to say some things probably that will have to be edited out off the cuff, and I'll probably try and make you laugh about things. This is a serious topic, but first of all, I guess I'm wondering, there you go. So my own background briefly, the thing I love about this whole industry is that, to use Mr. Wardle's theme here, the river of experience is something where you can stay in the same industry and have a whole bunch of different mini careers. So as I started out, I had graduated from a fancy Ivy League school with a dual degree in architecture and forestry that didn't exist yet. So I went right back to my home state and started being really literal about hyper-local, sitting there stacking rocks, doing timbers, stacking straw bales, biosourced, and wood was in my DNA. And then as things proceeded to a second career, the mass timber, see if I can go back to that, the mass timber trend I'm involved now on the regional level with large wood buildings that are having a big impact and moving into sectors that are currently dominated by steel and concrete. And as a note, that building is made of trees that are only 4.5 inches at the tip. So the tiny trees that are burning in northern Alberta right now for lack of thinning are actually the ones that could be made into products like this. And that has recently led to a third endeavor for me. Even though I'm an East Coast guy and our forests don't burn, it really hit me in the gut to go to Northern California and see what was happening there. So I've been back multiple times to that fire zone, and I'm really interested in broad federal binational policy change to reintroduce forest thinning, get back to fire safety, and ultimately to reestablish sawmills across what's really a sawmill desert. I mean, I drove around Alberta here, a lot of small trees, not a lot of sawmills left, You could probably drive south along the eastern flanks of the Rockies all the way to New Mexico and see a lot of the same things. So it's time to bring it back. I also want to overcome some misconceptions. I feel like the wood industry is not really well known. Or outside of us, people don't realize that, number one, this is an industry dominated by robotic fabrication, and we've been doing this a long time. When most of the 3D printer guys were in diapers, there were 60-foot robots out there cutting major building parts. A lot of those pieces of equipment are European, so we had to use single software, multiple outputs. Interoperability has been the norm for us. It's not a new thing. And so now that we're into discussing carbon, we are really working on open source and sharing data. And I think those are the two big trends that are going to accelerate this industry, already are accelerating this industry. And that's why you're probably going to see each of one of these people in some headline about what they're doing soon. So I really love that you're all here to see trendsetters, because this stuff's going to move really fast. So with setting the table on that, I would love to go all the way back to it's still not easy. Even if the manufacturing is mature and the pipelines are solid, the architectural community is faced with basically new materials, new structures. It's a young industry, and I'm really glad we have a young hometown person here who's also engaging, taking that challenge on. And so I'm going to hand this on to Stephanie, and she's going to talk first about the challenge of actually getting new materials specified in a traditional practice.
Thank you. So a little bit more about DIALOG is we're an integrated practice, so that really helps us facilitate having a holistic conversation on meeting any embodied carbon reduction goals or sustainability as a whole, as well as we're very committed to achieving low carbon and sustainable projects and addressing all the challenges that our communities meet, and we practice both in Canada and the US. So I included this slide because I think it's quite impactful, and it's the climate stripes if anyone's not familiar with it. So it's an average of a couple of decades, and as you see, the trend is the temperature rise, and we're right now in the darkest part of it. And this is what's really spearheading this climate imperative conversation. So most recently, the federal government, as well as municipalities across Canada, have all publicly established either carbon metrics on whole buildings or carbon reduction goals on specific components. And concrete's been the big one that everyone talks about because it's such an energy consumer in the A1 and the A3 category, as well as you start to see a lot of professional associations like the AIA, the RAIC, really a call to action to their membership of committing to a low carbon future. And some examples are the AI Materials Pledge, the SE 2050 for structural engineers, that by 2050, the intent is any firm that signed on to this commitment is your structural elements will be zero. And by 2040, the mechanical and electrical engineers have also done their commitment. So you're starting to see a lot of traction in the professional industry, but also industry advocacy, like through the wood Canadian construction industry of Eli advocating for that, the Canadian Cement Association, the Canadian Green Building Council through their zero carbon standard. You're starting to see it everywhere. So as a consultant, we start to use the life cycle assessment as a way to actually evaluate how are we doing with our buildings, how can we optimize the materials, the design of it, the quantity of it, and we start to look at the A1 and the A3 because that's where a lot of the carbon is coming from. So it's like where your materials are getting extracted, manufacturing, and just before it leaves the manufacturer. The newest potential is looking at the D category, where I'm glad I'm joined by Eric because that's where we really need to tap into that industry of how do we tactfully look at the materials and the way we design our buildings for designing for disassembly, circular economy, and repurposing all the materials and have an infrastructure in place to allow that. The next one is two examples of a deep energy retrofit. So the whole carbon discussion is not only about new buildings, but it's an opportunity to look at the existing infrastructure in Canada and understand the relationship between the operational carbon and the embodied, and how can we start to reuse some of the existing infrastructure. A local example is the McKimmie complex and the Hunter Commons at the University of Calgary, where we saved a significant amount of embodied carbon, about 6,100 metric tons of carbon, by just retaining the structure of it and then adding a double skin facade in order to meet our net zero target. So it is achievable in Canada and in a really cold climate that you can actually meet any of the net zero targets. And then for the future of it is hybrid wood towers. So when you start to have the conversation of using a product that sequesters carbon while also introducing a carbon-intensive product like steel and concrete. And we've been working with the industry on what is the viability of a mass timber tower of over 100 stories. What's the cost? What's the life safety? We've also partnered with the federal government to get it tested. So we know that if there is a life safety incident, the mass timber with the structure, the steel, is actually able to meet any of the building code requirements, the operational side of having a tower that big, as well as the embodied carbon reduction goals. So I will pass it off to Anneli.
Okay. Thanks, Stephanie. I'm going to keep it pretty high level because I feel like we're all after lunch a little bit low on energy. So hopefully hammer the most important points home. So for us as an organization, our role, the role that we want to play in this industry, is helping shift from carbon emitting materials to carbon sequestering materials. It's that simple. And the thing they need to do in order to turn buildings into a climate solution is you need to know where you're at right now. You need to start measuring your embodied carbon footprint, your material sustainability footprint, and understand, where are we at? Where's our baseline? So this might be a statistic that you're all familiar with. If not, I would recommend memorizing it. Building materials are responsible for 11% of all greenhouse gas emissions globally, which is huge, right? I don't have that slide in there, but if I did, you would see that that's more than fashion and flights combined. So it's a huge, huge emitter of carbon emissions globally. And this really wants to skip this slide. There we go. And it's not just structured. So a big misconception in this space is that, we just need to pay attention to concrete and steel. Those are very big emitters, and, moving towards timber, mass timber as a solution, is huge in getting us to actually start sequestering carbon en masse. But as you can see here, over the course of a building's life cycle, the green is the interiors. Commercial buildings get renewed, retrofitted, remodeled, whatever word you want to use, every 5 years, typically. And over the course of a building's life cycle, that's on par with or above the carbon emitted upfront from the structures. So we have to start measuring this across the building. We can't just focus on the foundation and the structures. Eli mentioned some legislation. Stephanie kind of touched on that too. There's a lot of movement in the legislative space, which is really exciting. This is one of the few sustainability spaces where the government is slightly ahead of the private sector, I would say. And so we have pieces of legislation like in Toronto, there was the Toronto Green Standard that was just passed, a month ago, 3 weeks ago? Super, super exciting because what it does is it actually starts to tell us where we need to be aiming. And where we need to be aiming is 350 kilograms of CO2 per meter squared for all projects, right? And so that starts to move us in a unified direction, whereas there's been a lot of kind of general net zero goals that don't actually give you really actionable points. In California, where Eric and I are both based, there is Assembly Bill 2446, which requires a reduction of 20% embodied carbon by 2030, I believe. Yeah, 2030, and then by, I think, 2035, it's a 40% reduction. So in development terms, that's pretty soon. And so what we do is we have a software platform that tracks, manages, and reports on embodied carbon of projects across your portfolio. We also track material health and other attributes that you might be tracking. I simplify it to embodied carbon because that's the space that we're mostly focused on today. And do I have another slide? Yes. So how it works is you can set embodied carbon goals, you can select products that meet those goals, and you can report out to your stakeholders, whether that's legislative bodies or your end clients. But we are really focused on the owners and developers that need to be driving this. And some long-term benefits include legislative compliance, ease of entitlement, particularly in areas like California where they have their own sustainability goals they need to hit, and then attracting money for your next fund as a developer from these institutional investors that have made net zero commitments. So I won't talk about our team. They're very experienced. You should be impressed. But yeah, I'll pass it off to Eric.
Cool. Thanks, Anneli. So good afternoon, everyone. So we are on the robotics automation side. So one of the keys to sustainability is waste. And unfortunately here in North America, we waste a lot of materials, especially in construction. And so one of the things that we're focusing on in every machine is lumber. So as those buildings get remodeled every 5 years, torn down 20 to 60 years typically, most of that material heads to an incinerator or a landfill. And that is high value material, whether it's a wood building, steel building, concrete. If you tear it down, that's a lot of energy involved. And so at Urban Machine, we are focused on the lumber side. In the United States, it's about 37 million tons of dimensional lumber heads to our landfills and incinerators every year. To put that in perspective, that's about half of what we log from the softwood forests in the US. Canada has very similar numbers, a little smaller, obviously smaller country in terms of population. The other thing about lumber is it has a dramatic impact on housing. You know, one of the big challenges here, not just in North America, but around the globe, is the cost of housing has increased. And this was really exacerbated during COVID when lumber prices spiked. Obviously, those producing lumber loved it, but those that were buying lumber on the contractor and developer side, it was a huge hit and rose prices quite dramatically, 10 to 20% on homes, which is a pretty big uptick in North America. The other elephant in the room is landfills. So in the US, they figured out that in the next 60 years, all the landfills will be full. Lumber is one of the major contributors to landfill waste here in North America. The state of Michigan did a study where they figured out if they tore down all the condemned homes that they have and abandoned ones, it would top off all their landfills that year. And so they had to go find another way. And so they've been doing a lot of research into reclaiming lumber. And so the key goal that we're focused on is how do we make it circular? One of the most sustainable materials is one that already exists, right? How do we reuse existing materials that we've already harvested from the forest, that we've already made into components, because it has the smallest carbon impact in terms of reusing it from an existing structure. And so what we're doing with lumber is we're closing that loop, right? We're taking a material today that's currently not recycled, aside from maybe cogen fuel and bark chips for some landscaping, whereas steel and concrete both have recycle paths. They're pretty carbon-heavy recycle paths, but they're recycle paths nonetheless. And so it's a little bit less carbon than the virgin steel, which is better, whereas wood does not have that opportunity today. And so what we're doing is we're leveraging some of the latest in technology. See if my video plays here. There it goes. To build robotics. So we're using all the fancy AI that all the people talk about, and we're actually putting it to work to solve real-world problems. We've trained our machines to remove literally nails, screws, and staples. We're pulling nails from wood. Because what's holding wood back from recycling is the metal fasteners. So all these engineers and architects have specified these awesome fasteners to hold our buildings together, and that has prevented wood from being recycled. Because once those fasteners are removed, then you can use it again to build new buildings. The majority of the wood that we process is clean, it's strong, it's actually a much higher grade than what you get from the forest today, because it was logged 40 to 100 plus years ago. So it's very tight grain, it's beautiful material out there. And so we're using that latest in technology, so essentially we're a tool manufacturer, to automate that process, because pulling nails is labor intensive. How many people in this room have pulled nails? There we go. Everybody's got a story. We were at the Mass Timber Conference, and it was everything from that was my first job, my dad made me do it, to, I've got a home project. So we're doing that with robotics, because robots are great at doing a highly repetitive task. And then the goal is to get it back into the environment, because wood offers a couple big advantages that steel and concrete don't have. One, architects love it. It's a much warmer material to use on the walls than concrete and steel. Two, we can actually track the story of it. And this is one of the fun benefits. We can actually track where we got the material from. So a lot of times we're going to be processing on demolition sites, and so we can track the history of that wood. We can throw a QR code on it, and then you can say, in that new building, you can hit that QR code and it gives you the history of the material. So when you can share that story, that's a fun, warm thing of not just cleaning materials, but actually sharing the history of where it came from and how it got turned into a new building. And the cool part about wood is we don't have to melt it down, we don't have to grind it up. The carbon required for reclaiming lumber is about 90% less than it was to build that virgin lumber. So it's a tiny fraction compared to steel and concrete, making it an incredibly sustainable material. And you can turn it into all kinds of products. You can build with it, you can do furniture with it. We've got a bunch of pilot customers, and it's a fun product, a fun material to work with. So if you want to learn more, hit up our QR code. We're still a young startup. We're only a little less than 2 years old, but our first machine hits the field here in a couple weeks. And we are working with architects on specifications. So how do you deconstruct buildings to maximize the return of recovery of materials? Working with designers on how do you specify reclaimed lumber in new buildings? How do you use it in mass timber products like Eli mentioned? And that's one of the big important things, right, is how do we get it into the specifications? Because a lot of times the projects, like Stephanie's working on, they may not start construction for 5 to 10 years, right? It's a long ways down the road from when it starts a spec or a drawing to when it actually goes to construction.
This is awesome. Thank you, everybody. And we're doing really well on time, so I want to make sure everybody knows you're going to get to them, but I get to them first here. So we're going to ask some more leading questions about, you can see how there's a vertical between how to specify something, how to report and check in with your team and colleagues, how you're actually doing and meeting policy goals, and then how to have an assurance that the things that you are designing can go on not only for the life cycle of the building, but for the next phase. So it's a pretty awesome string there. And in my work in the US, I'm going to start with Stephanie here, because I know she's a front lines right now on this challenge of Canada has this mandate, and you're going to have to figure out how to do that. And my optimistic piece of that is I work in the US representing many of the Canadian producers who have really risen to the top level of qualifications on how to build all these big new building types. And these are small companies in many cases. One of the things I feel like Canada does pretty well is, while the US is still gonna fight about whether or not we're gonna go down the path, Canada's actually implementing policy now that's gonna train not only you as a specifier, but it's gonna train all the manufacturers to report what you need. It's gonna train the software. And we will all be better for the fact that Canada's doing this, even though I think you should probably tell a little more about what a pain point this is gonna be for your firm right now, right?
Yeah, so I think the biggest gap in the industry right now is access to data. The data exists on understanding what the global warming potential is of products, but you can't equally access it. It's a bit of a pay to play. So having software like Tangible Materials, where a consultant, you can actually holistically look at the impact of your building from health and social equity, because in Canada it is a bit of a tunnel vision where everything's been about carbon lately, and an assumption of, well, if I reduce my global warming potential, all the other environmental impacts are going to be reduced. That's not necessarily the case. If you are interested in knowing, well, what's the durability of a product? What's the social equity? How am I going to repurpose that product afterwards? That data doesn't exist. There's a lot of circular economy discussions, but the infrastructure in Canada right now is lacking to allow the material reuse and tracking of materials through like a material passport that's done in Europe.
This would be really exciting. And again, having Stephanie be pushing for this is great. As I work globally, though, it's honestly, Canada is probably going to be a couple steps out ahead, not just because of this, but because of specifiers like Stephanie. There are some Right now, there's export requirements. Nobody who's buying exported wood wants to buy Russian wood by accident right now, for instance. So both the EU and Japanese markets have put in geolocation requirements. Canada is stepping up and saying, yeah, we do know where our wood comes from. And so it's kind of on us as a wood industry, and I'm speaking about our North American wood industry. We have lagged behind in generating the core documents called the EPD, environmental products. Those documents are needed, they need to be rolled out a lot faster, but the wood industry is not as simple as the concrete industry. We can't do a hierarchical EPD generator overnight. And so we're still going to be working on catching up, but for the Canadian practice community perspective, generally speaking, your grid is powered by hydro. Your manufacturers are really automated and handling all their scraps. And so the footprint, when the data comes out, the footprints are going to be among the best in the world, but it takes painful pressure to get that footprint out of there. And then it takes software that can handle that dynamically. So I want Anneli to talk about that, because the data we know is going to get better, but it's not great right now. So how does your platform take that up, and where are you taking it next?
Totally. So what this looks like for us is, adding in that x-axis of tracking over time. Because the way that reports have been done for the industry, whether that's a lead report or something else, is a very static one-time assessment. And, as I mentioned earlier, we also need to be tracking the materials that are replaced and, taken out of the building over time. But we also need to see how our baselines change over time and how that tracks to our net zero goals. So if you imagine, here's your y-axis and your x-axis. If this is 2050 and we need to get to zero, what does that trend line look like, right? And as the data becomes clearer and clearer, the ability to update reports with refreshed data, the ability to add in new baselines, this is the role of technology, right? Like we need to be doing this at scale. We need to be doing this in an apples to apples way. We need people to be seeing the same information. And so that's what we're hoping to solve for. One thing that we've talked about is, building in versioning for reports, because it might be that, the baseline used to be, at, 50 kilos of CO2 for this product, but actually the industry has really progressed, and so now it's a lot lower. And so being able to update that over time and being able to see how your projects track over time is really important. So we see this as, it's all very much powered by material data, and as the data becomes higher and higher fidelity, that will become more and more accurate. Right now, it's not going to be 100% accurate. We're really blunt about that, but even an estimation is better than nothing, than not knowing at all.
Could you speak some more too, Anneli, about this? So architects are good at indicators. If you give an architect an indicator what their building's got to do, energy efficiency being the classic, they get really good at doing that.
Totally.
But this carbon thing is coming on so strong that architects are barely equipped to do that. So I put up an example of a blended carbon use intensity as a possible metric that might come out in policy. You actually mentioned a number of 350 kg per meter cubed. Can you speak a little bit more about since you're flexible about what you're reporting to, what are the other things like carbon use or others that you might see coming?
Yeah. So the leading places for this are France and Denmark. They are tracking carbon usage not just for embodied carbon, but across the usage of the building as well. And so it's a total per square meter carbon number that you have to hit on an annual level. In Denmark, I believe that's 4 kilos of CO2 per square meter. It's extremely low. Not immediately, right? That's, I think, about 15 years out, but that's where we're aiming, right? So if that's what we think about kind of the long-term being, again, we need to baseline ourselves. We need to know where we're at right now so that we can know kind of what the slope of that curve is. And the one other piece of policy or guidance that I'll mention is SBTI. So this is the Science-Based Targets Initiative. Really fantastic organization. A lot of corporates have signed up for SBTI. And more real estate companies are also starting to follow their guidelines, but SBTI has only had guidelines for energy use in operations versus embodied carbon, and they just came out like last week with their guidance for embodied carbon. And that's super exciting because it's a science-based, really rigorous assessment of like, what do we need to get to? What are the step changes that we need to make? So those are things that we're incorporating as well.
So you're thinking your platform's gonna be built out dynamically to the reporting requirements that your users need, basically?
Yeah, and so we're focused on North America because, you know, this is the market that we're based in right now. But as we expand, we foresee ourselves being able to overlay the different legislative measures that apply to a given project.
That's awesome. I can speak to, I mean, with 3 out of 4 of us doing our daily business in the US, the reality is that most of the time I get a call and I'm like, Eli, we have 15 minutes to try to get, you know, a carbon, you know, a better version of this building that's probably gonna go steel and concrete.
Yeah.
What do you have for us? And you know, and we're doing this on our own time, and our colleagues aren't even sure they want to do this.
Yeah.
So the thing that changes us, though, is, which is why I love where Anneli is focused, is that owner-developers have a bunch of different ways of looking at a building. And they are going to own that building, they're going to get better rents for that building, and they're going to drive all of their consultants in ways that actually policy can't even touch. So I do think there's also a free market version of this. And one of the ones I heard recently was the owner-developer was like, you know, I used to ask builders for a guaranteed maximum price. Now I just want a guaranteed maximum carbon. There's just, you go figure it out. Here's where I want to hit. And that's the kind of thing that can happen. That's why I want to emphasize, like, policy's great, but also having tools that can really hit that quickly for business decision makers seems like a really good, I think you're really onto the right track. But you also mentioned where your clients are coming from. You want to share with that?
Yeah, so they're all Canadian. So if you're a Canadian developer, let's chat. Mostly in the multifamily space. And because there's a lot of immigration to Canada, there's a lot of need for more housing. We're going to keep building, and so how do we build sustainably? It happened to be kind of coincidental, but it's also helping us to kind of focus in on what are the major policy incentives and things like that we need to focus on. One thing I was also going to mention to your point, Eli, is the pressure coming from investors. That's been the biggest driver across our clients and the folks that we speak to, even though they're aware of the legislation, and more specific legislation like the Toronto legislation I mentioned is huge. It's BlackRock, CalPERS, APG, all of these big pension funds that have net zero goals and are saying to the companies that they invest in, like, hey, real estate asset managers, guess what? We need to measure this now. And they're putting it in their due diligence questionnaires. So that's where the biggest pressure is actually coming from, we've seen. That's awesome.
I'm going to go over the top now, and I think Eric and I will go back and forth on this, because obviously I'm a new forestry guy, and Eric's got this awesome tool to deconstruct buildings. But they're actually inextricably linked, and I'm going to start with this idea that if this is really ever going to be in Stephanie's spec, and if she's writing a book that an owner is going to follow, at some point there's a deconstruction bid. At some point it's a scope of work. And it gets really real in a hurry. So what I would love to hear Eric talk about a little bit is do you see something coming that's like a deconstructibility index? Are people measuring how deconstructible a building is in the same way that we're measuring all these sort of pre-construction topics?
Yeah, especially around, we're seeing people start to wise up, and a lot of the standards used to start when you started new construction. And so they completely ignored site prep, they completely ignored demolition of an existing building. If you tear down the existing building and send it to a landfill, which is pretty standard practice in most of North America, that's a huge hole in your carbon footprint, right? Because you're sending steel, wood, plastics, glass, all that to a landfill. And so you start off in a really tough challenge to try and get to net zero if you just demoed a building. Especially when you look at all the carbon inside of it and that you just put away. And so what we're seeing is a lot of people are starting to require deconstruction. It's still early on. It's been mostly pushed through legislation at the residential level, but we're seeing it at the commercial where it's actually quite viable. where you can actually deconstruct buildings for less than demolishing them. Because the material that's available in those, especially older buildings, you know, if you go back 40, 50, 100 years, the lumber, the steel, the components in those buildings are incredibly thick and high quality. And so a lot of times you can deconstruct those buildings, reuse many of those materials at a lower cost than you can for demolishing it. And so we work with a lot of demolition contractors, and the biggest delta is just the schedule. They need a little bit more time to deconstruct a building versus demolish it and smash it up. But when you look at, you know, waste fees are, you know, 100 to 150 bucks a ton, and most demolition contractors, if you say, hey, we'll take that material off your hands for free, they jump up and down and they're like, absolutely, right? How many truckloads can we give you guys? Because otherwise they're paying to haul it and tipping fees at a landfill to get rid of it. And then the owners are very interested in, okay, if this isn't gonna cost me more money and it's only gonna take a couple more weeks, and then I get to save some of the history from the previous building, then you get the architects and the owner on board as well. And so really it's just changing a historic, this is how we've always done it, and getting people to wake up and say, hey, yeah, we've always been doing it because it used to be a lot cheaper. But today it's a lot more expensive to demolish buildings than it is to deconstruct most of them. And we're seeing this really in a lot of the urban areas, you know, whether in Toronto or Vancouver, you know, San Francisco, California, a lot of cities are tearing down those old single-story, two-story warehouses, industrial areas to put in the high-rise residential. Those buildings are incredibly easy to take apart, and they have really high-quality material in it. And so there's absolutely no reason not to deconstruct those and reclaim the material from those. And it's great that we're adding more housing, but let's not throw things away in the process. Let's use that material in the new building. And so you're seeing legislation following that. Vancouver, British Columbia's got it. Portland, Oregon's got it. San Antonio, Texas, right? So imagine a city in Texas mandating deconstruction. So that gives you guys some ideas that, hey, it's not politics. This is just practicality of let's stop wasting money on throwing materials away.
And your concept for at least one version of your robot is that you could have it trailerized and back up to a job site and handle stuff there?
Yep. Yeah, so our goal, so one of the things you'll quickly learn about waste materials, you know, with wood is, you know, when wood is virgin and it travels on a flatbed truck, it's nice, neatly stacked and heads down the highway. When you fill it full of nails, screws, and staples and bolts, it does not travel on a flatbed truck, right? Then you move to dump trucks. And one of the things that we learned early on is those dump trucks are typically about 50% air. So they're only hauling about half their weight capacity. So it's really expensive to haul waste material around. And so our machines will actually go to the job sites, clean the wood on the job site, then we can bunk it up, ship it on flatbeds to the wood manufacturers. And our goal is to get it within 100 miles, full loop. So from where we source it, a demo site, to a wood manufacturer, back into a new building within 100 miles. And when you look at the virgin wood industry, they're 1,000 to 2,000 miles. You know, if you use my Texas example, a lot of times they're importing Canadian lumber all the way across the United States to get it in there, which is a lot of diesel fuel to get it down there. So there's a lot of opportunities to create local sources now because you can harvest material from urban environments and turn it back into raw material in those environments to bring down housing costs and make it available to industry.
Yeah, that's cool. Just to close the loop and then head out into audience questions here. As a forestry guy, it breaks my heart to practice all the sustainable forestry, even doing the things that aren't measured, like building good forest carbon soils. And then when that wood could go into the wrong end of life scenario, it could be making methane and just basically, you know, you've actually, the local recycling practice or landfilling practice has basically negated all the benefits. So you really do have to think about all the stakeholders involved to calculate a full life cycle, and I think having them all here is a really great opportunity for the audience now to ask these guys some questions and hear what your thoughts are. We have about 10 minutes, so.
I have a question for all of you. One of the biggest challenges I think I see is this: how do you track and compare these embodied carbons when the materials are so vastly different over time and are trending so different? How do you get a measure that you can actually create a comparison to deliver to developers?
Yeah.
I'm gonna ask a quick housekeeping question. Should I repeat questions for the camera, or do you think you have a good enough read on that? So I'll recap this one, and then we'll do mics from here as this is being recorded. So the gentleman asked about how do you actually track carbon in such a dynamic, changing, new materials, evolution.
Yeah, to really get an understanding of the comparison.
Yeah, it's a great question. So 3 answers to this. One is looking at it on a per square meter, per square foot basis. That's really, the end goal, right? Like zooming out, forest for the trees, how are we trending on that prorated basis over time? And that's the aggregation of all of the products used in the building, not just one product at a time. So that's where we want people to really focus is, are we on track or not? And if not, what are the products, what are the areas that are pushing us over the edge? What are the things that we can do to make swaps, make substitutions, even once the drawing is complete? And for us, what we kind of look at is products in the same product category. So if you're looking at, a flooring sample, for example, there can be a pretty big delta. For insulation, some of the insulation products that we have on our site are like a 90% reduction in embodied carbon compared to the baseline. And so if you can make those swaps at scale, that really adds up. When it comes to totally different designs, right now we don't really support kind of different models, different high-level models. But what you can do is you can create 2 different versions of the same report, basically, of the same building, and see how things kind of stack up. You can also compare side by side if you want to compare, a vinyl flooring with hardwood, but then you need to make sure that you're also accounting for all of the other changes you need to make to your design. So it is challenging because, for example, with wood, the great thing about using wood, if you use plywood for, your walls is you might not have to use paint. You might not have to use all of these finishes. It's going to be a different assembly. And so actually, in the end, you're using less material. So it's being able to compare across those types of decisions that, gets a little bit more challenging. In terms of how we think about product evolution or like new materials, I think we're just trying to stay up to date with the industry and, where there is data on baselines for different product categories, surface that, help people understand where a product sits. But for the new products, the mycelium insulations of the world, we'll surface data where it exists, but we also want to showcase new products, even if they're still new to the market. So we're striking a fine balance, I would say.
And that's exciting too, because this is an innovation conference, and the material transparency movement is essentially a rear view mirror of more mature products. So having software companies and practitioners willing to get out ahead and basically build supplemental database, talk to innovation pipeline, and begin to say something about new products. That's what drives market. So I think that's awesome. And I'd also add that from the industry side, we're trying to build essentially reliable calculation engines on quantities and assemblies so that software like Anneli's doesn't have to build that from scratch, and so all the methodologies are transparent, because there's all the data, but there's also how much material is actually in the building, and that's something that we should help with. Great question. We could probably go on that one. I'm going to ask for another one from...
So my question is for Eric, and my background is in civil engineering, and as you're talking about reusing wood, gets me very excited. One question I have is, when you take out nails or different kind of attachments to the wood, from a structural integrity point of view, does that pose a challenge? And then how do you resolve those challenges that come up?
Yeah, so the great part about lumber is the grading rules on virgin also apply to reclaimed. So essentially you're counting knots. So a 2-inch plumbing penetration hole would count like a 2-inch knot in the grading rules. And so typically in that example, you would cut that out. But if you're looking at a nail that's a 1/16 inch to an 1/8 of an inch diameter, it doesn't have any real structural impacts on the wood. So we apply the exact same rules. Glue lam's a different story. Right now there's no rules or any real grade stamps on glue lam, and so we're looking to change that. We're going to be sponsoring some research projects to find a way to regrade glue lam and other engineered products, so those can be reused structurally. But on the lumber side, yep, you can reuse it, and a lot of times it's a higher grade than what you get today.
The other exciting thing about this this robot that he and I have talked about on the side is that it opens up the avenue for new scanning technologies. So you just like visual grading, you can also use various ultrasound or X-ray scanning technologies to assess, has the wood, actually maintained, or is there internal rot or other things. So it's a platform, I think, that's going to have huge potential that way. Our next question.
Thank you very much for the wonderful discussion here. I'm a professor in mechanical engineering at the University of Alberta, and I also work in robotics and remanufacturing, recycling, and on the mass timber side. So I'm really excited to see this urban machine. So my question from Eric is, when you recycle a product, usually it costs more when you look into plastic recycling, for example. It's usually 3 times the virgin material. So how do you look into that? Can you talk a little bit about the cost model there? And then also, who's your competitor? Like, is there any other company, similar company on the international level? Thank you.
Yeah, so real quickly, so our goal is to compete with virgin lumber and to bring down the cost. So today, reclaimed lumber is about 5 to 10x virgin lumber because it's typically hand done. So with the machines, our goal is to compete with the mill price and do it at scale. Because we know some environments you'll have green premiums that people will pay for the reclaimed and the carbon benefit. But if I go down to Dallas, Texas, for example, it's purely a cost economics equation. And so we have to compete in order to scale on that one. And then the second part of your question was?
Competitor?
Competitors. Yeah, our competitor is about $1.5 million grinder that turns it into wood chips. We do not have any other robotics companies that we're aware of. We've talked to people out of Europe, out of Australia, New Zealand, Japan, all across North America, and nobody else is aware of anybody else that's doing this with robots.
Awesome. There's a ton of questions. We'll keep this moving. Go ahead, sir. The mic's right behind you.
Sure. Thanks. So replacing steel and concrete with sequestering material like wood is a great progress in things. My question is from the other side, glass. Around 30% of envelope is glass, and even the production side is more centralized in that recycling. We don't have that opportunity. Do you see any improvement trend in that part? And of course, float glass manufacturing is a heavily carbon-intense industry. And what do you see? What are your thoughts about that?
You want to take that one?
Yeah, Stefan.
Yeah, sure. So we actually explored that on McKinney because there was just so much glass, and unfortunately at the time there wasn't infrastructure in place. But in the US, they're starting to repurpose float glass IGUs to be part of concrete. So like as a glass polyzen. So that's another alternate path, because some of the issues with IGUs is how old it is, the seals on it are toxic, and also trying to remove the low-E coating that's on the glass, you have to physically destroy the glass. And so right now, that's one of the viable options of repurposing glass through as an end of life, as a completely new product would be concrete.
And
Yeah, go ahead, Anneli. I'll go after you. This is a great topic.
yeah, no, it's a great question. I used to work at the Better Buildings Partnership in the UK, and when I was working there, there was a case study from British Land, I believe, where they basically refurbished a project in the middle of central London where they actually did glass refurbishment on site. Or I say on site, it was like a block or two away, but it was basically on site where they actually disassembled the glass and refurbished it, polished it up, whatever, and put it back. I don't know that that was cost effective, but I do know that I think there's a lot of opportunity for us to use the existing glass that's out there and be a little bit smarter about it. I think there are ways to incorporate, more modular design, things that are a little bit less bespoke as well, which can be repurposed a little bit more. But in terms of technologies to get the carbon footprint of glass down, it's hard. I think electrifying the process can help somewhat, but ultimately the raw materials are highly extractive, right? You're basically firing sand in a giant kiln. So I think modifying designs in the kind of model of passive house or something else is maybe a bit more the answer, where it's a little bit less glass. Like we're using a lot of glass in commercial towers, and we might not need to use quite so much.
Yeah, she said exactly what I was hoping to hear. So I'll I'll go right to the next question, but there are some metrics, some policy areas dealing with actual embodied carbon are putting in a window-to-wall glass area. And I just want to remind people, especially when you're getting into mass timber, there's larger beams and everything else. So there's some really handsome old mill buildings that are not 100% glass. They make a huge difference. There's a lot of great questions here. I want to urge people to come find us, look us up on LinkedIn. I think we could probably, yeah, I'm not sure if we should wrap now, probably. So thanks everybody. Thanks Alberta Innovates, and we hope to see you all around the campus.